In the comments on my last video I was asked to explain how a pipe organ tremulant worked, so this is what this video is all about. I thought I'd start by reading from Audsley's book The Art of Organ Building on the section on the tremulant, and he says, "The small mechanical appliance known as the tremulant or tremulant is found in the generality of modern organs of any importance, where it is introduced for the purpose of imparting a tremulous or undulatory effect to the tones or speech of certain stops at the will of the performer." First of all, we have to understand the effect of changing the wind pressure on the note of an organ pipe. Here we have a principal pipe, I think it's a G, and I'll show you what happens when we blow the pipe, and as we blow harder you'll see the pitch change in this instrument tuner. So by affecting the wind pressure we can make a tremulant effect on the pipe. Let's have a go using my mouth. So the tremulant is simply a mechanical device to achieve this in the organ. If we return to Audley's book The Art of Organ Building, we can see in the tremulant section a cross-section drawing of a tremulant very similar to the one that we have on the bench at the moment. The bottom section here is connected up to the wind supply via a trunking, and this pallet here is a valve that allows you to turn the tremulant on and off by blocking air entering the upper chamber. This upper section here is the tremulant itself. We have a fixed chamber and then we have an upper board that moves up and down. When the tremulant is at rest, this pallet here is allowed to be open, and when the tremulant's activated, wind flows around the pallet up into this upper chamber and lifts the moving board at the top. By doing so, this closes off this pallet valve L here, reducing the air supply into the upper section. The upper section also has a couple of outlets, so it means that when it's moved up, the air is able to escape out, and because this lower valve is shut, the pressure in the upper section reduces again, and the weight of the top board and the spring causes it to move back down. Moving back down then opens this pallet valve again, letting more air into the upper section, and it moves up again. So you create a pneumatic mechanical oscillator, and if you have it set up right, it will resonate, and that will cause pulses of air going into the tremulant and escaping, which will then cause pulses of air in the air supply and pulses of air in the reservoir, and in effect pulses of air to the pipes themselves, and that will cause them to speak louder and quieter, and also higher and lower as it tremulants. So here is my tremulant set up on the bench. You can see I've connected it up to my workshop blower. It's connected directly, there is no reservoir in my workshop, so some of the action of the tremulant is going to be overly aggressive compared to on an actual organ. Connected to the side of the tremulant we have a simple manometer which will indicate the air pressure by moving this coloured water up and down in the line, and I put a hole on here so we can put a pipe and connect the pipe up to the wind and see how it works. And then here's our tremulant, very similar to the one in the illustration in Audley's book. We've got a lower section here which has got the mechanism for turning it on and off, and then we've got an upper section with the tremulant with the moving top board. So I'll turn my wind supply on and we'll see what happens. So with the wind supply turned on, you can see the first thing that happened is the manometer has indicated that we've got about 4 inches of water height, so air pressure. And if we put the pipe on, we can get a note. Now this pipe is sounding slightly unsteady because it's being a bit overblown by this pressure, but that's not the effect of the tremulant. So if I hold the mechanism, I can try and get the tremulant to start. So there we can see the top board vibrating, causing a tremulant effect, and it's also causing pulses in the pressure, so we can see it's affecting the air pressure back in the line. And if I put the pipe on, you can hear the effect it's having on the pipe. Now, I remember back to my days mechanical engineer that the resonant frequency of an oscillating body is dependent on the stiffness of a spring. Well, we don't have a spring here, and we've got the stiffness of the leather and the inertia of the mechanism. It's also dependent on the weight, so we can change the resonant frequency of the tremulant by adding a weight to it. So I've got some bits of old lead tube from a tubular pneumatic organ. If I put them on the tremulant here, we've made it heavier, which will affect the resonant frequency of the tremulant. So there we go, we can see it's vibrating a lot slower now. And if we put the pipe back on, so we're going to start by taking the cover off this lower section to look at the mechanism that turns the tremulant on and off. The tremulant shown in the picture in Audley's book came from a mechanical action organ, whereas this one's come out of a tubular pneumatic organ. So there's some slight differences. At the bottom down here we have what's known as the primary pneumatic. So this would connect up to the stop action by this tube here, so that when you pull the stop to draw the tremulant, this pneumatic would be inflated like so. It would lift a valve in here, which would then exhaust the air from this pneumatic motor, this pallet motor. The pressure inside the wind chest would then push down on the pneumatic motor, and as a result it will pull down on the pallet above, and that will then let air into the upper section, which is what activates the tremulant itself. So this is a very similar mechanism to the key action in a tubular pneumatic action organ, as if one of these was for each key. We'll move on now and have a look at the top section of the tremulant. So if we remove the top section of the tremulant here, firstly we can look inside and see we've got an empty chamber, and here's the pallet that we saw earlier that turns the tremulant on and off. Here we have the top section of our tremulant. We've got the moving top board and the fixed lower board, and underneath we can see the pallet valve, and when the top board is down, the pallet valve is open, allowing air into the top section of the tremulant, causing it to rise. which also closes the pallet valve, and at the same time we've got the escape valve on the top plate, so that when it's risen the air inside is allowed to escape, allowing it to drop back down, which opens the valve, lets air in, restarts the cycle, causes the tremulant to go up and down, which causes a pulsed escape of air and a pulse pressure in the wind chests and a wavering pitch of the pipes.